Hello, everyone, and welcome to the ETHOnline 2023 Filecoin Workshop DataDAOs on the FVM. Joining us today is Zach Aish, who will be taking us through this session. And with that, I'll pass it over to Zach to get the session started.
Hey, all right, thanks. Yeah, excited to be here. My name is Zach. If you don't already know me, I'm a developer relations engineer at Protocol Labs, specifically within the FVM, Filecoin Virtual Machine team. And, today I'm going to talk to you about what the Filecoin Virtual Machine is, kind of the basics of Filecoin, and we'll go into some specific applications you can build on the FVM, specifically DataDAOs. Right. So the Filecoin master plan, if you're not familiar, step one is build the world's largest decentralized storage network. And that is already checked off. Step two, onboard and safeguard humanity's data. And I think this is a mission that goes on forever, right? We won't have all of humanity's data on Filecoin at any one time, but we want to get as close as we possibly can, right? And step three is bring compute to the data to enable web scale apps. And this is where the Filecoin virtual machine comes into play. Right? So the Filecoin virtual machine project delivers on-chain programmability to the Filecoin network. And we'll talk about what that means specifically here in a second. So some of the most common questions that we still continuously get and misconceptions we get is, what's the difference between Filecoin and IPFS? Where do they sit? How are the two related? A lot of people seem to know that they're interconnected. Filecoin and IPFS are actually two separate networks, right? You have IPFS. It's got its network of nodes and computers where you can pin data. And you have Filecoin, where we can think of it as layers, where we have a layer 0, which is Filecoin, the storage layer. This is the storage providers who are running the Filecoin nodes. Layer 1, you can kind of think of it like a 0.5 is really what I think about the FVM, because it's built into the node software. It's not like another chain or another compute environment plugging into Filecoin. It is in Filecoin. And you have the layer 2s where you can program actual dApps on the Filecoin virtual machine. Right, so on IPFS, you can run your own node and or run a bunch of your own nodes and pin data to it. You can run nodes with the community, and if the community really likes a specific piece of data, they can run nodes and keep that data alive. Or you can run your own node and pay for a pinning service to keep data alive, right? So IPFS is all about getting data stored and retrieving it through its content identifier. But this does not give you guarantees that the data will stay up and live. If we're paying for a pinning service, this might introduce like a centralization vector into the dApp, which not all dApps want to accept, right? So this is where Filecoin comes in, right? So you have the storage provider network here at the bottom. They're all running their nodes. In the middle, you see the Filecoin blockchain. This is actually being run within the storage provider network here in each of the nodes. So this is kind of like a logical thing. And this is kind of acting as a middle layer between these storage providers and clients who want to store data with these storage providers, right? So a storage deal is made on chain, and this kind of crypto economically incentivize these storage providers to store data and gives clients a way to store data in this more decentralized environment. Right, and now to make things a little bit add another layer of complexity within this blockchain, being again run by all these storage providers, is the Filecoin virtual machine, right? Which allows compute to happen within the blockchain. And in this case, the Filecoin virtual machine is actually running the Ethereum virtual machine within it. And this allows us to make custom logic around storage deal metadata for like storage and retrieval. You can make, for instance, data DAOs, and we'll talk a lot more about the other types of applications you can build. So to get an idea of the actual architecture of what the Filecoin virtual machine looks like and the Filecoin node. So if we were to zoom in on one of those storage providers in the earlier slide and look at the software they're running, they'll run a Filecoin node. The most popular is a Lotus node. And within that, again, lives the FVM. And it is actually built using WASM time. So it's actually built with WASM. And within the FVM is a virtualized EVM, right? So kind of like how you can run a hypervisor on your computer. And if you're running a Windows, you could virtualize a Mac OS on there, or vice versa. If you're running Mac OS, you could virtualize Windows. Within these nodes, the WASM time is a virtualized Ethereum virtual machine, right? And this is the first runtime that is actually live. And in the future, you could have actual native, we call them native actors. You could program smart contracts and anything that compiles to WASM and deploy those to the chain, but that isn't live yet, right? In the future, there's the possibility of services such as Renew as a Service, interplanetary consensus subnets, native user-defined WASM actors, new foreign blockchain runtimes, right? So this is one of the advantages of this design paradigm, is that we don't have to settle for just a single runtime, right? If another virtual machine takes off in the Web3 space, and that's the one that most projects are building around, the FVM can be adapted to use a new foreign runtime, right? And it could even be a non-blockchain runtime, right? So for instance, the native WASM itself, and possibly any other runtime that you may find useful to run in a Web3 space. But since the EVM is the first runtime live, the FVM is compatible with all of your favorite EVM tools, and this is why the EVM was the first runtime to be virtualized in the FVM, right? So you can use Remix, you can use Hardhat, Foundry, MetaMask, all of your favorite kind of tools that you're used to building with in the Web3 space. Slide. So why should you use FVM over all these other EVM compatible chains around? And the answer is storage deals, right? This is a unique feature that isn't available on any other chain, because remember, Filecoin is based natively around getting data archivally stored, long-term storage. And with that comes this idea of storage deals, right? So what is a storage deal, right? So we talked about how the Filecoin blockchain kind of sits in between clients and storage providers actually store this large data. And on-chain, and this distinction is often confused, but on-chain, the data that we're storing with the storage providers does not live on-chain anyway, right? That'd be incredibly expensive. And it's the reason why blockchains tend not to store large data sets in the first place, right? Like NFT images are often stored on IPFS and increasingly so on Filecoin. And so Filecoin is around for what's actually stored on chain is the deal, right? So it's like the metadata of the data being stored with the storage providers, right? It's all of the data around how long that data is going to be stored, when it was created, who the client is, who the provider is, how big the piece size is, which is ultimately the data that's being stored with the storage provider. Is it verified on Phil Plus or not? And what are the fees being paid to that storage provider over the time, right? This is what governs the actual data being stored with the storage provider, right? And this is what crypto economically guarantees that data storage. So if every provider needs to put up stake, and with that stake, they need to provide proofs on chain that they actually have your data stored, right? So we call them proof of replication and proof of space-time. And if they do not provide these proofs, proof of space-time like every day, then they get slashed, right? And they do not get paid. So they have all these crypto economic incentives to keep your data stored, and if not, suffer the consequences. So again, just to make this distinction crystal clear, what isn't a storage deal? So what can't I access in the FVM? The actual data stored with storage providers, right? Again, that would be way too heavy, way too expensive to actually use in the FVM, and that's why Filecoin was created in the first place, to kind of create the infrastructure to maintain this data in a decentralized way, but not actually keep it all on chain. So we have the Filecoin virtual machine. We have these storage deals, which are native primitives to Filecoin. The EVM doesn't know about storage deals, though, right? It doesn't know about Filecoin, for that matter, right? It knows about Ethereum addresses. It knows about how much in the case of Ethereum, how much ETH. In the case of Filecoin, how much FIL is in every account. But it doesn't know what a storage deal is. Right. And so in conjunction with a team called Zondax, we created these Filecoin.solidity libraries, which is called Filecoin.sol. Right. And these act as abstraction layers between you, the Solidity dev, and the low level primitives that you need to access these storage deals in your dApps. Right. So if you were to go in there, you could go into contracts. You would find a contract called market.sol. And that provides some getter functions that you can use to get, live deals structures into your dApps and write logic around it. So again, storing data is really what Filecoin is all about. And so if you want to store data, you have three kind of paths you can take. Perhaps you don't need programmatic storage. You don't need to use the virtual machine for anything. You just need to get data stored. You can always store data like you always could on Filecoin outside of the Filecoin virtual machine, and just make a deal with a storage provider. And this can actually happen off chain. You can go to a storage provider marketplace, find one offering a good deal you want, or find one you think you can negotiate a deal parameter. And what you actually do is you sign that deal. That deal goes to the storage provider. They'll also check up on it and say, okay, this is actually good. They'll check that the data that you're actually storing with them hashes to that PCID, which represents the data. And if everything checks out, they'll call a method on chain with your signature, and the storage deal will become active, right? But perhaps you want to do this in a programmatic way, right? You want to somehow use the Filecoin virtual machine, for instance, making a DAO, like we'll see later, around these, like making storage deals, right? Well, if you actually want to store small data, which most hackathon participants do, and they're not like have these giant data sets, we actually recommend we go with what we call deal aggregation, right? Or using an aggregator. Big aggregator we recommend is Lighthouse.storage. They've been great at taking the latest features being available on the Filecoin virtual machine and integrating them in with their aggregator. And they'll abstract away the pain of making a deal for you, right? So you can call them through an SDK, or you can call them through a smart contract on chain, and they'll take your data, they'll prepare it to be stored, and then they'll aggregate it with a bunch of other people who want data to be stored, and they'll make a deal together on chain with a storage provider for you. Now, where this gets all ultra convenient, and what we really like about Lighthouse.storage and what they've done is they'll actually provide you what's called a proof of data inclusion, data segment inclusion, or POD-SCI, right? And remember, they're aggregating data among not just your data set, but they're combining it with all this other data, then making a deal, right? So how do you know what deal your data sits with? So you could possibly contact a storage provider yourself and get it back. Well, they'll provide you a proof of data inclusion on chain that says, hey, your data is aggregated in with this other data and stored with this storage provider, and here's the proof, right? So that's the advantage of using the data aggregator. But if you're feeling a little bit more savvy, you want to make deals yourself, you can use what we call direct deal making on chain with something called the client contract. And there's actually a deal making starter kit, and you'll have a link to that at the end of the presentation. But that allows you to make deals directly with Boost storage providers on chain. And you can do so by calling a function that emits an event that these Boost storage providers listen to. But this can be a lot more complicated, as you have to know the precise ways to make a deal. And if not, that deal might not go through, and that could be a whole round of troubleshooting, right? So, yep, we have those three paths. And again, for most people, I would really recommend the aggregator route, especially if you're going to be hacking in a hackathon. So what can the FVM solve? It can do what like many other Web3 virtual machines can do. It can do governance, tokenomics, endowment management. We're seeing DeFi projects launch, just traditional DAOs. But also we can build specific infrastructure around these storage deals, like repair workers that repair renew workers that will find deals that are faulty or about to expire and automatically renew them for you, and generate new storage deals, as I talked about in those three pathways through the client contract, right? So the FVM kind of supercharges the Filecoin ecosystem for storing data. And so you saw that, part of the label of the talk is DataDAOs. And if you're not familiar, a DAO stands for a decentralized autonomous organization. It really is just adding a governance process to smart contracts. So some smart contracts need things like upgradability and decision making that just can't be logicked away by ones and zeros in math. And in this case, we'll want to add a governance structure to our smart contracts to try to keep them as decentralized as possible, right? And this is kind of facetiously put in here about what is data. Data is a collection of discrete values, blah, 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 blah. I believe you all know what data is. But, data DAOs are combining these two things. And specifically, what I mean is, and what we mean at Protocol Labs is DAOs for storing data on Filecoin, right? You may hear the term used in other ways in other ecosystems, but when we're using it in Filecoin context, this is what we mean, right? So a DAO that governs data being stored with those storage providers. So as an example, my colleague Sarah came up with this idea of Biscuit DAO, right? The Biscuit Data DAO. It's a community of corgi owners that want to better understand their corgis. And so maybe you can think of Biscuit DAO as having ZK verified contributor to access the storage contracts, right? So we could have some kind of DID, decentralized identity, to verify who's doing what in the DAO. But these contributors, either way, they can upload data to the DAO throughout the week, and they can be minted tokens to reward corgi owners, right? And so this DAO could collect crowdfund money like Phil, or they can mint their own token for the DAO and reward people as they upload data to the Filecoin network, data that the DAO finds particularly useful. In this case, maybe health data on corgis, right? So as corgi owners participate in the DAO, they can get more tokens and further participate in DAO voting. And what can they do with this vote, right? So they can choose to train, for instance, AI with the data that's being stored in the with the storage providers, right? There's a project called LilyPad being built on top of Filecoin, which also seamlessly is trying to have a bridge between Filecoin and heavy compute AI. So you could kind of combine these two things and train AI models based on the data the DAO is storing. The DAO could vote to access and control the data set that is off chain for specific users. And of course, the DAO can vote on how to use the rest of the funds in the treasury, right? Maybe they want to get more data stored. Maybe they want to have access to DEXs and trade across currencies that they may find interesting, or fund these renew, repair, replicate deals I was talking about earlier, this infrastructure to keep the deals alive, right? So you can have this data that lives with storage providers, and the DAO can kind of perpetually fund that data to be stored permanently with their treasury. And in the end, you get healthier and happier corgis. Who doesn't love happy corgis? This little fellow looks pretty happy, if I do say so myself. And so I think, everyone kind of gets a happy end to the story. And while this is like a fun example, just to kind of make DataDAOs real, I see a lot of personal use cases. I see a lot of people coming in and doing it with cool ideas like scientific data. There was a project that wanted to take like oceanographic data that they were collecting in university and storing it in and using a DAO to kind of decentralize ownership of this data. You can actually find an MVP repo of Biscuit DAO that I built for fun at this link. Check it out. Again, it's just a demo for you to kind of go through, see some of the scripts that have been made, see some of the SDKs that were used. Front end is on the way. But yeah, so you can, when you're brainstorming a data DAO, this can maybe give you something concrete to start off with, right? And again, I want to shout out to Lighthouse Aggregator, which I talked about, and they've really been building out some really cool stuff. They have really good docs. I highly suggest you check it out. And they take advantage of all the latest technology, like that pod size you see here. Like, how do you upload your data and get a proof that your data has been uploaded on chain? Extremely easy to use, and keeping up to date with all the latest tech in the Filecoin ecosystem. And for something as more of a launching point, if you're thinking about building a data DAO, Biscuit DAO is just kind of a concrete example. We have a data DAO kit, which kind of has all of the building blocks that are not opinionated, that are just kind of there to show you some important building blocks you may need to use with some scripts, right? So Open Zeppelin governor contract, ERC20 votes contract, all Open Zeppelin standards here ready for you to use and take advantage of. And for some more general FVM resources, you can check out this link tree, which has everything before, and links to the GitHub forums, docs, use case ideas, and all their community discussions you may find useful. So yeah, thank you for listening. I believe this leaves us about 5 minutes or so for questions. So if anyone has any questions, I'd love to answer the Q&A.
Yeah, if anybody has any questions, feel free to type them in the chat or take yourself off mute and ask Zach directly.
Hey, Zach, thanks for the talk. It was really good. I had a question about LilyPad and the Filecoin virtual machine. Sure. Kind of at a high level, can you explain, like, if you're making a data DAO that would offload compute, like how that integration would work, or a good place to look to figure that out?
Yeah, so LilyPad is in like active development. I would say it's still kind of in an alpha beta phase. But I would suggest checking out their docs. The last I checked, the last I used, I know they just released a V2. And they also have a Slack channel. So I'll definitely check they have their own Slack channel. Check there if you want just like direct communication with the LilyPad devs. But last I checked, they were really, you could kind of create your own model that you wanted running it with Docker. And there was, LilyPad is more of a bridge between that compute environment and on-chain. And, like, for instance, you could run Stable Diffusion, get an image, and it would automatically store that image on IPFS and give you the CID. Now, because you have that LilyPad bridge, you could conceivably, like, have that data created and then call a function on chain to have that data stored in Filecoin, for instance, like some AI generated art, just some ideas, right? But yeah, if you want the latest status, I would definitely suggest checking out the latest in the docs and that their Slack a group.
Oh, thanks.
Yep.
Zach, thank you for walking us through that. I wasn't aware of FVM's capabilities.
Sure.
Specific use case, do you think FVM can be combined with Seismo, the other partner here at the hackathon, to create a data DAO and use Seismo for kind of selectively picking a group of people who can access that to upload the data or access that data?
I'm not familiar with Seismo, but if they have like Ethereum smart contracts, or there's some off-chain infrastructure that can interact with an EVM chain, yeah, sure. Like it's kind of the advantage of it being an EVM compatible chain is that like if it works on an EVM chain, it works on the FVM.
Got it. Okay, thank you.
Yep, no problem.
Yeah, and there were several questions that I resurfaced in the chat.
I see. Let's see. We got what are interchain capabilities of FVM? For example, does it support IBC? No, so it's not a Cosmos chain, right? So it is like Filecoin is its own blockchain that was built ground up. But I believe Axelar is live now as a bridge. And I think more bridges may be looking at coming live on FVM in the future, but I know Axelar is live. What will WASM development look like? For example, will we be able to use COSM WASM? I believe the WASM actors are they're still in active development, so there's still debate on what it will look like. This is something that'll come down the pipeline. I believe it'll be different. It's looking like most likely it'll be different from COSM WASM, but I'm not 100% sure what it will look like in its final state. Can we currently use FVM as an L1 for ZK rollups? Yep. Yeah, I know there's some projects working on L2 on top of Filecoin and the FVM, and also projects using the storage providers as a data availability layer for those ZK rollups and optimistic rollups, right? Also, there's like this kind of native L2 framework called IPC, not to be confused with IBC, interplanetary consensus, which is a way to spin up like L2 subnets with custom security properties on top of Filecoin. And question 4, a quick summary of the FVM's consensus algorithm. Basically, storage providers, you have to provide proof that you have hard drive space, but you also have to put up stake. So it's kind of this in between of a physical consensus with proof of stake consensus. And at that point, you have to take on storage deals. And that requires a little bit more stake being put up to get into the consensus, right? And I know we're running on time, so I'll try to get a couple of more questions here quickly.
Yeah, Liam had asked what sort of access control is available for storing private vulnerable data on Lighthouse FVM.
Yeah, I actually haven't messed around with Lighthouse's access controls. But again, their docs are super clear, so I'll suggest you just check them out. And their engineers are really, really supportive.
Awesome. I think that's all the questions then.
Cool.
Awesome. Well, cheers. Thank you, Zach, for the great workshop and presentation. And thank you, everybody, for attending. Hope your Monday's off to a great start. And yeah, we will be seeing you all again tomorrow for more workshops. Cheers.
Yep.
Have a good one.